Coming off the basic form of linear function with direct variation, we move into the first change from that, and that is the concept of a linear function, especially those written in what's known as slope-intercept form. Now, slope, simply defined, is a rate of change. And in a two-dimensional system, this rate of change is calculated by using the following ratio. And that ratio is the vertical change divided by the horizontal change. Now, vertical change you might hear referred to at times as the rise, and the horizontal change as the run. Now, our vertical axis, when we're traveling on a Cartesian graph, our up and down, is our y values. So this can be denoted with y as the change of y. This triangle picture is the lowercase Greek letter delta. Sorry, it is the uppercase Greek letter delta, and it means to change. So we have a change of y divided by a change of x. And the way we would calculate this, if we're given 2 points, then we're going to call them x1, y1 and x2, y2. The way we find our change of y is we take our second y value and subtract the first one. Now our change of x values, we take our second x value and subtract the first one. It really doesn't matter which point you call first and which one you call second. The importance is that the items for a single point line up with each other and that you are subtracting. Thing is, when we subtract our x's, we cannot come up with 0. So I'll put that in as a condition. x2 minus y2 cannot equal 0. Sorry, let me correct that real quick. x2 minus x1 cannot equal 0. As long as we don't fall victim for that, we are fine in calculating our slope, or our rate of change. Now, when we look at the overall system, there are 4 types of linear slopes. The first is positive. Graphs are read from left to right, same as a book is. So a positive slope is anything that is increasing as we move left to right across our surface. A negative slope is going to be anything that descends as we move from left to right. Now, 2 special types of slopes is the zero slope, and what this looks like is a perfectly horizontal line, no rise to it, and the undefined slope, which is a perfectly vertical line, has no run to it. Our zero slope is literally 0 divided by some other number, and our undefined slope is some number divided by 0. But of course you can't divide by 0. This is why we have an undefined slope. It says that we aren't moving anywhere right to left. We're just going straight up and down. So if we can look at a graph and see that if it's moving up or moving down, it gives us an idea of what we're supposed to be doing with our function. If you look at a function and are able to identify the slope, then knowing that that slope is positive or negative will tell us the general direction of travel of the graph. Aside from the general types of slopes that are included in linear functions, when we're looking at slope-intercept forms, we need to have this concept of what are intercepts. So intercepts, using this quick graph here, this one does have a positive slope. We have 2 different types of intercepts. We have an x-intercept, which is located where our graph crosses the x-axis, and we have a y-intercept, which is the location when our graph crosses the y-axis. An x-intercept is going to come out at the point of this x value and then our y value of 0. Our y-intercept is going to be 0 for x and then some y value for y. So as long as we're able to cross the axis or identify a location where that crossing would occur, we can find our intercept. Which brings us up to the slope-intercept form of the equation. Our slope-intercept form is y equals m, which represents our slope, times x plus some b value, which is our y-intercept. So again, our m is the slope, and it's whatever number is being multiplied by x when your equation is solved for y, and b is our y-intercept, or our starting point, and it's always given in the form of 0, b. Same thing here as what we had for our y-intercept up above. So being able to go through and looking at a function and identifying the pieces that make up our function, the slope and the y-intercept, will be very helpful when it comes to graphing it. So let's take a look at a couple of those. Here I have 4 different situations, all that can be modeled with a linear function. We need to solve some of them for y and then identify the slope and the y-intercept. Now for this first graph, our function, in order to solve it for y, we will subtract 5x from both sides of our equal sign. We have a negative 4y equals negative 5x, sorry about that, negative 5x plus 16. Then we divide by negative 4, and what we come out with is y equals 5/4 x minus 4. So in this, our slope is 5/4, which means between 2 adjacent points we're going to rise 5, we'll move up 5 lines, and run 4. It's to the right 4. And our y-intercept is the point 0, negative 4. Let's try another one. Negative 3/4 x plus 1/2 y equals negative 1. We can add 3/4 x to each side. And come out with 1/2 y equals 3/4 x minus 1. Now in order to get rid of that 1/2 y, we're going to multiply both sides by 2, because 1/2 times 2 is equal to 1, our multiplicative identity item. So we end up with y equals, that would be 6/4, which will simplify down into 3/2 x minus 2. So here, our slope is 3/2, which means between 2 adjacent points we will rise 3 and move right 1. And our y-intercept is the point 0, negative 2. Third problem. Make a little division here between our items. So our next one, we're solving it again for y. This will simply add 2x to each side of our equal sign. This allows us to isolate y, and we get y equals 2x plus 1. So our slope is 2, which slope's always a fraction, so we can write it as 2 over 1 if we need to as a reminder. And our y-intercept occurs at 0, 1. Last one, we're given pieces, we need to fill them in. So let's reverse the process of what we were doing before. We have y equals mx plus b. We're told what m is, and b is the y value if x is 0. So we come out with the equation y equals 1/5 x minus 3. And our slope and y-intercept are already identified. So as we go through and work with linear functions, this form of the slope-intercept is going to be very important. We will learn how to graph these, plot them on a line, and solve and work with the equations themselves. There's a lot that can be learned here, and graphing the points is very important, and we will cover that as we move forward into future sections.